Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces.
Today, we're looking at a paper that asks a really big question. We've built these incredible AI models, like the ones that can chat with you or create amazing images, but they still feel not quite human. They make weird mistakes, they hallucinate, and they don't really understand the world. So what's missing?
According to this paper from researchers at the University of Washington, the answer might be hiding inside our own heads. The title is Lessons from Neuroscience for AI, and it suggests that to build better AI, we need to make it more like our own brains.
It's a fascinating idea because in one very important way, today's AI is already a lot like the brain. Both are basically prediction machines.
What do you mean by that?
Well, think about a large language model, or LLM. Its main job is to play a constant game of what comes next. If you give it the sentence, the cat sat on the, its entire goal is to predict the most likely next word. Mat, rug, chair, whatever. It learns by making billions of these predictions and getting corrected when it's wrong.
Okay, so it's a super-powered autocomplete. How is that like the brain?
There's a popular theory in neuroscience called predictive coding, which says our brain does the exact same thing, but for everything. Your brain is constantly predicting what you're about to see, hear, and feel. When you walk into your kitchen, your brain is already predicting a table, chairs, a fridge.
And if something is different, like there's a penguin standing on the table, your brain goes, "Whoa, that was not in my prediction."
Exactly. That whoa moment is a prediction error, and both our brains and AIs learn by trying to minimize those errors. So they have this fundamental principle in common, but the paper argues that's where the similarities end. Current AI models are missing three huge components that our brains have.
All right, let's get into them. What's the first missing piece?
The first one is actions, the ability to actually do things in the world. Right now, most AIs are like brains in a jar. They can process incredible amounts of text and images, but they can't interact with anything.
Why is that a problem?
The paper gives a great example. An AI can read 1,000,000 sentences about avocados and write, "This avocado is soft," but it has no real idea what soft means. It's just a word associated with other words. It's never had the experience of gently pressing an avocado to see if it's ripe.
It's missing the physical experience. The concept isn't grounded in reality.
Precisely. The authors suggest to get truly intelligent AI, we need to give it a body, or at least a simulated one. It needs to be able to take actions and see the consequences. That's how it will learn that pressing too hard on an avocado makes a mess, and that soft is a sensation linked to an action.
Okay, so AIs need to get their hands dirty, virtually or otherwise. What's the second missing piece?
The second piece is what the paper calls compositional structure, which is a fancy way of saying building with Legos.
Legos?
Think about a complex task, like go to the grocery store. You don't think about every single muscle movement. Your brain breaks it down into smaller chunks. Walk to the car, drive to the store, park the car, get a cart.
And each of those chunks can be broken down even further. Drive to the store is made up of turn left, stop at the light, turn right.
Right. And the best part is you can reuse those little Lego bricks everywhere. The open a door brick you use to leave your house is the same one you use to get into the store. This hierarchical compositional structure is incredibly efficient.
And AI doesn't do this?
Not really. Current models tend to be monolithic. They look at a huge amount of information all at once in what's called a context window. It's like trying to build a Lego castle by looking at a giant flat picture of it instead of building it piece by piece. This can lead to problems like the AI forgetting what was said at the beginning of a long conversation because it gets lost in the middle of all that data.
So the recommendation is to build AIs that can think hierarchically, breaking big problems into small, reusable steps, just like we do. That makes sense. What's the third and final missing ingredient?
The final piece is episodic memory. This is your brain's personal scrapbook of past events.
So not just knowing that Paris is the capital of France, but remembering your trip to Paris, what you saw, what you ate, that time you got chased by a pigeon.
Exactly. That's an episode. It's a specific personal memory. LLMs don't have that. They have short-term memory, that context window we mentioned, but once information scrolls out of that window, it's gone forever. They can't form lasting memories of their interactions with you.
Which is why you have to keep reminding them of things you talked about yesterday, or even 10 minutes ago in a long chat.
Right. The paper suggests we should give AIs a system like the brain's hippocampus, a dedicated place to store important, salient episodes. This memory wouldn't just be for looking things up. The AI could even replay these memories, mix and match them to learn new things, and generalize better, much like our brains are thought to do during sleep.
So, to recap, the paper argues that to make AI safer, more efficient, and more human-like, we need to borrow 3 big ideas from the brain: actions to ground knowledge in the real world, compositional structure to solve problems like we build with Legos, and episodic memory to create a personal scrapbook of experiences.
That's the core of it. It's a shift in thinking. Maybe the future of AI isn't just about making bigger and bigger models fed with more and more data. Maybe it's about going back to the original blueprint for intelligence and building something with a structure that's a little more familiar.
A fascinating perspective that reminds us that after millions of years of evolution, the human brain still has a few tricks to teach its digital counterparts. That's all the time we have for today.
Thanks for tuning in to Daily Papers.